Hi everyone. Today we have our last topic that covers rational expressions and equations. And the topic today is how to solve equations that have rationals in them, so solving rational equations. In order to solve an equation containing rational expressions, you need to use all of the knowledge that you had from the last lesson and factor the denominators and find the least common denominator, the LCD, of every fraction in the equation. So let's talk about why that is. If you look at number 1, the denominator here is 2x minus 3. And then here, technically the denominator is 1. So my least common denominator is the 2x minus 3 and the 1, which really it doesn't matter if it's there or not because it's multiplying by 1. So there's my least common denominator, and in order to solve for x, which happens to be in the denominator, I need this to not be a rational expression anymore. I don't want any more fractions. And in order to undo the division by this denominator, I need to multiply by the denominator so that I can cancel it out. So if you multiply every term on both sides of the equation by the least common denominator, you're going to be able to cancel out all of the fractions. They're all gone. So in order to do that, you may have to do some simplifying, but eventually it'll all be gone. You'll be able to solve for x just like in a normal equation, but you do have to check for extraneous solutions, extraneous roots. Those would be any values that you get in the process of solving that make any denominator in the original equation equal to 0, because we can an x value that if I substitute here gives me 0 for the denominator, well then I can't do that in my solutions because that can't happen. So let's look at number 1. We already found the least common denominator, which is 2x minus 3. So I didn't have to factor. I found the least common denominator. I want to multiply every term on both sides by 2x minus 3. That way I can simplify and start solving for x. So I'm going to multiply both sides by 2x minus 3. If I have 2x minus 3 on top and 2x minus 3 on bottom, this is where the magic happens, and I can cancel out my fractions. So I'm just left with a 1 on the left side. And then here, 4 times 2x minus 3 can be simplified by distributing. So 4 times 2x is 8x, and 4 times negative 3 is negative 12. And now I simply solve for x using inverse operations. So I move my constant, 13 equals 8x, and I divide by my coefficient. X equals 13 over 8. Now before I can put that as my solution, which I would put in braces because I'm looking for my solution set, I need to check just to make sure that I don't have 0 for my denominator. So I'm going to take 2x minus 3 and I'm going to plug in my x value. So 2 times 13/8 minus 3. Think about the 2 on top. The 2 and the 8 are both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And 13 over 4 minus 3 is not going to be 0. This is okay. So my solution would be 13/8. So let's look at number 2. Number 2 has 3 terms. One has a denominator of x, the other one has a denominator of x. This has a denominator of 1. So my least common denominator has an x and a 1, so 1x. So I'm going to multiply all terms, 1, 2, 3, all 3 terms by x. So when I multiply by x, 5x over x, the x's will cancel out, and I'll have 5, plus 2 times x over 1 is 2x, and 6x over x, the x's will cancel out, and I will have 6. So I've simplified. I want to solve my equation for x, so I move the constant, 2x equals 1, and I divide by the coefficient, x equals 1/2. Before I write it as my solution, I want to solve and make sure that if I substitute 1/2 for x, it's not going to give me a denominator of 0. This denominator is 1. I can't even substitute x in there. But if I check to make sure that x doesn't equal 0, well, x is 1/2. And that doesn't equal 0. So this is okay. And 1/2 is my solution. So let's move on to example number 3. X is already factored. X plus 1 is already factored. X squared plus x is not already factored. I can take out a GCF here of x. X squared divided by x is x. X divided by x is 1. So that's what I can break my first denominator into. My least common denominator is all the pieces, everything that they share and everything that they don't share. Well, this is x and x plus 1. This is just x plus 1, and this is just x. None of them have anything that they share with all three. So I'm going to put in all the pieces of x plus 1 and x. So I'm going to multiply all three terms, 1, 2, 3. I'm going to multiply them all by x times x plus 1. And we'll see what gets canceled. So in the first rational expression, the x's will get canceled, the x plus 1's will get canceled, and all that remains is the 3. In the second rational expression, the x plus 1's will get canceled, and all that remains is the 3 times x equals. In the last rational expression, the x's will get canceled, and all that remains is the -1 times the x plus 1. Now I know that I should distribute, so this should be 3 plus 3x equals -x minus 1. I need to solve my equation for x, so I'm going to move my x's to be together. So I'm going to add x to both sides. I have 3 plus 4x equals -1. And now I'm going to do what I've done in the last two problems. I'm going to move my constant. I'm running out of space though. 4x equals -4. And I'm going to divide by my coefficient. X equals -1. Before I write my answer, I'm going to make sure that substituting -1 does not give me 0. So I can go ahead and substitute -1 into my least common denominator. X times x plus 1, that'd be -1 times -1 plus 1. That'd be -1 times 0, and that's a problem, because that means that we have a denominator of 0. That's not okay. If I plug in a -1 here, -1 plus 1 is 0. So that means that -1 is actually not a solution, it's extraneous. There's no solution that we can put, so we say no solution. Okay, let's look at number 4. Number 4, I have factors of x minus 2 and x minus 2, and let's see. Two numbers that multiply to give me -10 and add to give me 3. Maybe some kind of 2 and 5. But if the sum is positive, then that means the bigger number should be positive. There we go. So my least common denominator, all three rational expressions have x minus 2. But this one is not common, so an x plus 5 needs to be in there as well. I'm going to multiply all three terms by the least common denominator of x minus 2 times x plus 5. And let's see what happens. In the first rational expression, x minus 2's are common factors on top and bottom that can be canceled. What remains is 2 times x plus 5. Well, 2 times x is 2x, and 2 times positive 5 is 10, equals. The second rational expression, x minus 2, is a common factor on top and bottom. It will cancel out. I'm left with x times x plus 5. So x times x is x squared. X times 5 is 5x plus. And in the third rational expression, I have x minus 2's that cancel out and x plus 5's that cancel out, and all that remains is a 6. So this is a quadratic. I notice it's a quadratic. So I want my entire equation to equal 0 so that I can factor. So I'm going to move the 2x, and I'm going to move the 10. I have x squared plus 3x now minus 4. I'm thinking of two numbers that multiply to give me negative 4 and add to give me 3. So think about those two numbers. Some combination of 4 and 1, but if the sum is positive, then the bigger number needs to be positive. So when I get my solutions, the opposite of plus 4 is a negative 4, and the opposite of minus 1 is positive 1. So those should be my solutions, but I need to check and make sure that they work. So to check, x minus 2, I need to check. I don't want it to be equal to 0. If x is negative 4, that equals negative 6. That's not equal to 0. That's good. If x equals 1, 1 minus 2 is negative 1. That's not equal to 0. That's good. And then I also need to check for this factor. So x plus 5 I don't want to be 0. If x is negative 4, this is 1. That's not equal to 0. If x is 1, that's 6. That's not equal to 0. So both of these work. They're solutions. They're not extraneous. So my solution set is negative 4, 1. Okay, so we have 4 problems remaining. So what I'd like you to do is on problem number 5, I'd like you to identify the least common denominator. And once you identify the least common denominator, I want you to show the work of multiplying all 3 terms by the least common denominator. So pause your video, find the least common denominator, and multiply all terms by it. Pause your video. So the least common denominator is x plus 3 times x minus 3. You should have the work shown. If I'm canceling out common factors, I'll be left with 2 times x plus 3. So 2 times x is 2x. 2 times 3 is 6. If I cancel out common factors here, the x plus 3's will cancel. I'll be left with 4 times x. And 4 times negative 3. Notice how because I'm subtracting this term, I subtracted this in parentheses, so I need to watch for that. And then here, the x plus 3's and the x minus 3's cancel, remains. So distribute your negative. Combine your like terms. Move your constant. And divide by your coefficient. So we get a value of 5 that we now need to check. I need to check it with x plus 3. I don't want it to be 0, and I need to check it with x minus 3. I don't want it to be 0. Well, 5 plus 3 is 8. That's not 0. And 5 minus 3 is 2. That's not 0. So my solution set just consists of 5. Okay. So on number 6, go ahead and factor your x squared minus x, GCF of x, and you're left with x minus 1. Here there's a 1, and here there's an x minus 1. So my least common denominator has a 1, an x, and an x minus 1. I don't really need to write the 1 though. I'm going to multiply all terms, x minus 1. In the first rational expression, the x's cancel, and the x minus 1's cancel, leaving 2. In the second rational expression, nothing cancels. Negative 1 times x is negative x. Negative x times x is negative x squared. And negative x times negative 1 is positive x equals. And then here, x minus 1's cancel, and you're left with 2x. Again, we have a quadratic, so I want everything on one side, and I want my equation to equal 0. I'm going to reorganize. Negative x squared minus x plus 2 equals 0. I'm also going to factor out a negative 1, because I don't want my leading coefficient to be negative. Numbers that multiply to be negative 2 and add to be 1 would be some combination of 1 and 2. Because the sum is positive, I would want the bigger number to be positive. Here, the opposite of minus 1 is positive 1. Here, the opposite of plus 2 is negative 2. I need to check and make sure that neither of these solutions would give me 0 in the denominator. So if I substitute 1 for here, let's just check x, and let's check x minus 1. So if x is 1, that's okay. If x is negative 2, that's okay. If x is 1 here, 1 minus 1 is 0. That's not okay. So 1 is extraneous. And if x is negative 2, that's okay. So the only solution that I should be writing is the negative 2, because the 1 was extraneous. So pause your video, work on 7 and 8, and then check back for the work.